Hello, dear friends, and welcome. I'm so happy to have you here. As we begin, I'd love it if you could share in the comments where you're joining from and the time of day it is for you right now. It's always wonderful to witness people tuning in from across the world. Thank you as well to those who have already subscribed and shared their support by liking the videos. It helps more than you know. And please don't hesitate to leave your ideas or requests for future videos. Let's get started. Chapter 1: Understanding Ocean Currents, an Introduction. Ocean currents are the gentle, flowing rivers of the sea, weaving through the vast blue expanse that covers our planet. They are defined as continuous, directed movements of seawater generated by various forces acting upon the water. These currents are significant not only for their role in maritime navigation, but also for their profound influence on the global climate and ecosystems. Imagine for a moment the sheer scale of the oceans, where these currents act like conveyor belts, transporting heat, nutrients, and even entire marine species across distances that the eye cannot see. The significance of ocean currents extends far beyond the water's surface. They play a critical role in regulating climate by redistributing heat from the equator to the poles. For instance, the Gulf Stream carries warm water from the Gulf of Mexico up along the eastern coast of North America and across the Atlantic to Europe. This warm water influences weather patterns and contributes to milder winters in regions that would otherwise be much colder. Can you envision the warmth of the ocean flowing like a nurturing embrace, softening the harshness of winter for millions? In addition to temperature regulation, ocean currents also affect precipitation patterns and storm systems. They can influence the formation and trajectory of hurricanes, altering their path and intensity. This connection between the ocean and atmosphere is a dynamic interplay that scientists continuously seek to understand. The currents, like the heart of the planet, pulse with life, shaping not only the marine environment but also the terrestrial climate. The study of ocean currents has a rich history, marked by exploration, discovery, and a quest for knowledge. Early navigators relied on their observations of currents to guide their ships, experimenting with the ebb and flow of tides to chart their courses. One of the earliest documented studies was by Benjamin Franklin, who, in the 18th century, mapped the Gulf Stream using data collected from sailors. His work laid the foundation for understanding how ocean currents function. Franklin famously remarked, "The sea is a vast and wonderful book, and it is only by the study of its currents that we can hope to read it." His passion for the ocean and its mysteries sparked interest that continues to this day. As we delve deeper into the study of ocean currents, we can trace advancements in technology that have allowed scientists to explore these phenomena with greater precision. The invention of the thermometer, the use of satellites, and the development of buoys have all contributed to our understanding of oceanic movements. Each technological leap has enabled researchers to collect data from remote areas, unveiling patterns and trends that were previously hidden beneath the waves. But what are the main factors that influence ocean currents? Several key elements come into play, shaping the flow of water across the globe. One of the primary drivers is the wind, which, acting on the surface of the ocean, creates friction that initiates the movement of water. Imagine the gentle caress of a breeze on a calm day, stirring the water into a slow ripple. As the wind pushes the surface water, it sets off a chain reaction where the movement continues deeper into the ocean, propelled by the Coriolis effect. This phenomenon, resulting from the Earth's rotation, causes currents to curve, creating distinct patterns that define our oceanic highways. Temperature and salinity also play essential roles in the formation of currents. Warm water, being less dense, tends to rise, while colder, saltier water sinks. This difference in density creates a process known as thermohaline circulation, often referred to as the global conveyor belt. Imagine, if you will, a great oceanic machine where warm water travels along the surface, cooling and sinking, only to be replaced by the deep, cold waters rising to take its place. This intricate system connects all the world's oceans, fostering a global network that regulates climate and supports marine life. Another significant factor influencing ocean currents is the geography of the ocean basins. The shape of coastlines, the presence of islands, and the layout of underwater topography all create friction points that alter the flow of water. Currents can be deflected, split, or intensified depending on these geographical features. Picture the way a river bends around rocks and islands, each twist and turn creating its unique flow. Additionally, tides, caused by the gravitational pull of the moon and sun, introduce another layer of complexity to ocean currents. Tidal currents can vary greatly, creating a rhythmic ebb and flow that can enhance or disrupt existing currents. These tidal movements contribute to the mixing of waters, bringing nutrients from the depths to the surface, which is vital for marine ecosystems. As we explore the intricate web of forces influencing ocean currents, we begin to appreciate the delicate balance that sustains our planet. From the smallest microbe to the largest whale, every organism in the ocean is connected through these currents. They are not merely pathways for water, but are lifelines that distribute nutrients, oxygen, and warmth, supporting vibrant ecosystems that thrive beneath the surface. The study of ocean currents continues to evolve, with researchers dedicated to uncovering the mysteries that lie beneath the waves. As we look to the future, we recognize the importance of understanding these currents not just for scientific inquiry, but for their implications on climate change and environmental health. With the planet's climate in a state of flux, ocean currents are changing, and their impacts can be felt far beyond the coastlines. The delicate balance of our ecosystems hangs in the balance, reminding us of the interconnectedness of all life. In this ever-complex world, the ocean currents serve as a reminder of nature's power and resilience. They beckon us to explore, understand, and protect the vast blue heart of our planet, inviting us to join in the journey of discovery that has spanned centuries. As we continue this exploration, let us keep our minds open and hearts engaged, for the ocean has much to teach those willing to listen. The influences on ocean currents extend beyond physical forces, weaving in the threads of atmospheric conditions and human activity. Atmospheric circulation patterns, driven by uneven heating of the Earth's surface, create prevailing winds that shape ocean currents in profound ways. Consider how, as the sun warms the equator, warm air rises and creates low-pressure zones, while cooler air from the poles sinks, forming high-pressure areas. This dance of air creates trade winds and westerlies that, when they sweep across the ocean's surface, set the stage for currents to follow. Imagine standing on a cliff, watching the wind ripple through the ocean's surface, creating tiny waves that cascade into larger swells. Each gust of wind contributes to the movement of water, demonstrating the interconnectedness of the atmosphere and the sea. This dynamic interplay is not merely a curiosity. It is vital for understanding how currents can transport heat and moisture across vast distances, affecting weather patterns far from their origin. Among the remarkable figures who have contributed to our understanding of these interactions is Matthew Maury, often considered the father of oceanography. In the 19th century, Maury meticulously gathered data from ship logs and crafted the first comprehensive charts of ocean winds and currents. His insights illuminated the relationship between atmospheric conditions and oceanic movements. Maury once stated, "The ocean is a great highway. highlighting the importance of understanding how these currents not only facilitate navigation, but also influence climate and weather patterns. As we contemplate the implications of human activity on ocean currents, it's essential to recognize the impact of climate change. The warming of our planet alters the delicate balance of temperature and salinity, which in turn affects the density-driven aspects of ocean currents, such as thermohaline circulation. Imagine the consequences of these changes, where the very currents that have sustained life for millennia begin to shift in unpredictable ways. Research indicates that alterations in ocean currents can have far-reaching impacts on marine ecosystems. As currents change, so too do the distributions of nutrients and marine species. Coral reefs, which rely on the flow of warm and nutrient-rich waters, may struggle to adapt to these shifting currents, putting entire ecosystems at risk. The intricate relationships between species, their habitats, and the currents that support them highlight the fragility of oceanic life. In addition, as we explore the future of ocean currents, we must acknowledge the complexities of pollution and its effects. The introduction of plastics and other pollutants into the oceans disrupts not only the water quality, but also the flow of currents. Picture the implications of debris traveling across the ocean, carried by currents that have no regard for human-made boundaries. The currents serve as both pathways and barometers of the health of our oceans, responding to the pressures we place upon them. As we trace the paths of ocean currents, we also encounter fascinating phenomena such as upwelling and downwelling. Upwelling occurs when winds blow across ocean currents, pushing surface water away and allowing deeper, nutrient-rich waters to rise. This process supports some of the most productive marine ecosystems, creating vibrant fishing grounds that sustain communities. Can you envision the teeming life that flourishes in these nutrient-rich waters, where the convergence of currents brings sustenance to countless species? Conversely, downwelling occurs when surface waters converge, sinking and carrying oxygen to deeper layers of the ocean. This process is vital for the health of deep-sea ecosystems, where organisms rely on the oxygen transported from the surface. As we consider these intricate processes, we begin to appreciate the delicate balance maintained by ocean currents, which nurture life from the surface to the ocean depths. The future of ocean currents is intertwined with our actions today. Scientists are continually monitoring these currents, utilizing advanced technology to gather data and make predictions. With the advent of autonomous underwater vehicles and satellite imagery, researchers can now examine currents with unprecedented precision. Imagine the vast amounts of information flowing in, each data point contributing to our understanding of the ocean's complex systems. As we ponder the journey of ocean currents, we are reminded of the words of oceanographer Sylvia Earle, who said, "The sea is the life support system of our planet." This sentiment echoes the responsibility we share in protecting these vital systems. The currents that weave through the oceans are not just physical phenomena. They are the lifeblood of our planet, sustaining ecosystems, influencing climates, and supporting human communities. In this chapter of exploration, we find ourselves at the intersection of science, history, and the future we wish to create. The tides of change call upon us to engage with the mysteries of the ocean, to listen to the currents that carry stories of resilience, adaptation, and interconnectedness. As we continue our journey, let us remain attuned to the whispers of the ocean. For in understanding its currents, we come closer to understanding ourselves and our place within this magnificent blue world. Chapter 2: The Role of Wind Patterns in Ocean Currents. Wind patterns are the unseen architects of the oceans, shaping the currents that flow across vast expanses of water. These patterns originate from the sun's energy, which warms the earth unevenly due to its spherical shape. Regions near the equator receive more direct sunlight, creating warm air that rises and leaves behind a void filled by cooler air from surrounding areas. This continual movement of air creates what we know as wind, a fundamental force that drives ocean currents. As we explore the intricate relationship between wind and ocean currents, let us consider how surface winds serve as the initial catalyst for the movement of water. When the wind blows across the surface of the ocean, it exerts frictional force on the water, creating a transfer of energy. This interaction sets the water in motion, generating currents that can travel vast distances. Imagine the gentle caress of a breeze stirring a tranquil pond. Now picture that same force acting upon the expansive surface of the ocean, igniting a complex choreography of water movement. Understanding the direction of these winds is crucial in comprehending how currents are formed. Wind patterns are not random. They follow specific paths largely dictated by the Earth's rotation and the distribution of landmasses. For example, the Coriolis effect, a result of the Earth's rotation, causes moving air and water to turn and twist. In the northern hemisphere, winds curve to the right, while in the southern hemisphere, they curve to the left. This can lead to the formation of gyres, large systems of rotating ocean currents that can span thousands of kilometers. Can you visualize these colossal whirlpools, quietly spinning amidst the blue vastness, guided by invisible hands? One of the most prominent wind patterns influencing ocean currents is the trade winds, which flow from east to west in the tropics. These winds play a pivotal role in the movement of warm water across the equatorial regions. As the trade winds push the surface water westward, they create a buildup of warm water in the western Pacific, which is then pushed down into the depths. This process not only affects local climates, but also contributes to significant phenomena such as El Niño and La Niña, which can have global repercussions. Another significant wind pattern is the westerlies, which dominate the mid-latitudes. These winds blow from the west to east and are responsible for driving ocean currents like the Gulf Stream. As we learned in the previous chapter, the Gulf Stream is a major current that transports warm water from the Gulf of Mexico up along the eastern coast of North America, making its way across the Atlantic to Europe. The influence of the westerlies on the Gulf Stream exemplifies how wind patterns can impact not only ocean currents, but also climate and weather systems. In addition to the trade winds and westerlies, there are also polar easterlies that flow from the poles towards the mid-latitudes. These winds can influence ocean currents in polar regions, pushing cold water away from the continent and allowing warmer waters to circulate. This interaction is essential for maintaining the delicate balance of marine ecosystems in these frigid waters. As we delve into the fabric of these wind patterns, it becomes evident that they are not merely forces of nature, but rather intricate systems interwoven with the rhythms of our planet. The work of scientists like Ferdinand Magellan, who first navigated these ocean currents in the 16th century, and Matthew Fontaine Maury, who charted the winds and currents of the oceans in the 19th century, laid the groundwork for our understanding of these powerful natural phenomena. Maury famously stated, "The winds and currents are the great highways of the ocean." This insight reminds us that just like roads on land, these currents guide the movement of not only water, but also ships, marine life, and even the distribution of heat across the globe. Imagine the vastness of the ocean, teeming with life, as currents carry nutrients from one region to another, fostering ecosystems that flourish in seemingly isolated patches of water. The interplay between wind and water creates a symphony of movement that sustains countless species, from the smallest plankton to the largest whales. Each gust of wind, each ripple of water, contributes to a greater narrative of life beneath the waves. In contemplating the role of wind patterns in shaping ocean currents, we are reminded of the interconnectedness of our world. The currents are not just carriers of water, they are also conduits for warmth, nutrients, and life itself. They support fisheries that provide sustenance for millions and regulate the climate patterns that influence weather systems across continents. As we journey through this understanding, we might ask ourselves, what would happen if these wind patterns shifted? How would the delicate balance of our ecosystems be affected? The ongoing study of ocean currents and wind patterns illuminates their profound importance, revealing how even the slightest change can ripple through the entire system. Scientists continue to monitor these shifts, understanding that changes in wind patterns due to climate change can lead to alterations in ocean currents, which in turn can impact global weather and marine biodiversity. In essence, the relationship between wind patterns and ocean currents is a dynamic dialogue, a constant exchange of energy and matter that shapes the world we know. As we listen to the whispers of the wind and the gentle lapping of waves against the shore, we are reminded that the ocean is alive, a breathing entity that reflects the rhythms of the atmosphere above. In this vast expanse, currents swirl and glide, guided by the invisible currents of air above them. They work tirelessly, quietly influencing everything from the temperature of our seas to the life cycles of marine creatures. The next time you find yourself by the ocean, take a moment to pause and appreciate the unseen forces at play. Feel the wind on your skin and know that it is intricately linked to the currents beneath the surface, a tapestry of life and movement that connects us all. The intricacies of wind patterns extend beyond their immediate effects on ocean currents. They also interact with the Earth's diverse climate zones. The atmosphere's dynamic nature means that as winds shift, so too do the currents they influence. Picture the scene where warm, moist air rises over the tropics, creating an area of low pressure that draws in cooler air from surrounding regions. This constant dance of air masses is not just a spectacle of nature, but a significant driver of oceanic movement. In the tropics, the trade winds, which we have already touched upon, are primarily responsible for the formation of the north and south equatorial currents. These currents move westward and are essential in redistributing warm water to the western Pacific. But have you ever wondered how this warmth affects the weather patterns far beyond the oceans? When these currents travel, they not only influence temperature and precipitation along coastal regions, but also affect weather systems thousands of miles away. The ocean's surface is the meeting point where these atmospheric processes converge. When the sun shines brightly over the ocean, it warms the water, which in turn influences the air above it. The warmer air rises, creating an area of low pressure, while the cooler, denser air rushes in to fill the void. This cycle generates wind, which weaves its way across the ocean, stirring the waters below. As we consider the broader implications of these interactions, we should turn our gaze to the role of the westerlies once more. These winds, blowing from west to east, play a pivotal role in the formation of significant ocean currents in the mid-latitudes. The westerly winds drive currents such as the North Atlantic Drift, which is an extension of the Gulf Stream. This current carries warm water across the Atlantic, moderating the climate of northwestern Europe. Imagine the comfort of a gentle breeze that carries warmth across chilly waters, bringing a touch of summer to distant shores. In the southern hemisphere, the westerlies also influence the Antarctic Circumpolar Current, the world's most powerful ocean current. This current flows continuously around Antarctica, connecting the Atlantic, Pacific, and Indian Oceans. It is unique not only for its strength, but also for its role in regulating global climate by facilitating the exchange of heat and nutrients between oceans. What would happen if this current were to change? The answer lies in the very fabric of our climate and ecosystems, where even slight modifications can lead to significant shifts in weather patterns and marine biodiversity. As we explore these wind patterns, we cannot overlook the role of scientists who have dedicated their lives to understanding these complex systems. One such individual was Sir Francis Beaufort, known for developing the Beaufort scale, which measures wind force based on observed sea conditions. His keen observations of wind and water helped pave the way for modern meteorology and oceanography. His words resonate as a reminder of the importance of careful observation. The sea, once it casts its spell, holds one in its net of wonder forever. The magic of the ocean lies in its ability to connect distant places and peoples through the currents born from wind patterns. As these currents transport warm and cold water, they create zones of upwelling, where nutrient-rich water rises to the surface, supporting robust marine ecosystems. When we contemplate the interconnectedness of these systems, we realize that they are not just pathways for water, but vital highways for life itself. Consider the migration patterns of marine species, such as the majestic sea turtles, which travel thousands of miles across ocean currents. These currents are their guides, steering them to nesting sites and feeding grounds. It is a remarkable journey, one that is intricately tied to the very winds that shape the water they swim through. As we reflect on the significance of wind patterns and their influence on ocean currents, we can also ponder the human experience. Across history, sailors have relied on these winds to traverse the seas. The exploration of the oceans has always been an endeavor fraught with challenges and triumphs. Early navigators, equipped with little more than the stars and the whispers of the wind, charted courses that would change the course of history. Their bravery and curiosity remind us of our own connection to the sea and the currents that flow beneath us. What stories might the ocean tell if it could speak? Perhaps it would recount tales of storms and calms, of migrations and discoveries, of life thriving against the odds. The currents, driven by the winds, create a narrative that is as old as time itself, woven into the very fabric of our planet. As we journey further into the understanding of these magnificent systems, we see that the interplay between wind and water is a delicate balance, one that requires our attention and respect. The world is watching, and as the winds continue to shift with climate change, the impacts on ocean currents will undoubtedly be profound. How we respond to these changes will define not only the future of our oceans, but the health of our planet as a whole. Let us take a moment to breathe deeply, to appreciate the vastness of this interconnected web. The winds whisper their ancient songs, while the currents hum a melody of movement that resonates throughout the globe. Each breath of wind, each ripple of water, is a reminder of the beauty and complexity of nature. The oceans, with their ever-changing currents, are a testament to resilience, adaptation, and the enduring power of life. Chapter 3: Earth's Rotation, the Coriolis Effect Explained. The Coriolis effect is a fascinating phenomenon, a quiet but powerful influence on the movement of ocean currents, shaped by the very rotation of our planet. As the Earth spins, the complexities of its motion create a unique framework that affects everything from weather patterns to the currents that flow across the vast oceans. Imagine standing on the surface of a merry-go-round, where everything appears to move differently depending on your position. This is akin to how the Coriolis effect operates, an intricate dance of forces that give rise to the currents we observe in the sea. At its core, the Coriolis effect arises from the rotation of the Earth. As the planet spins on its axis, different latitudes move at different velocities. The equator, spinning at the fastest rate, is like the outer edge of that merry-go-round, racing ahead compared to the slower speeds found near the poles. This difference in speed affects the path of moving objects, including ocean currents. When a current travels northward from the equator, it does so at a faster pace than the underlying ground, causing it to veer to the right in the northern hemisphere. Conversely, in the southern hemisphere, the movement shifts to the left. This seemingly simple twist has profound implications for the direction and behavior of oceanic currents. Consider the Gulf Stream, a prominent current in the Atlantic Ocean, which originates in the Gulf of Mexico and travels northward. As it flows, the Coriolis effect causes it to shift eastward, creating a warm, flowing river of water that influences climate on both sides of the Atlantic. The warmth of the Gulf Stream is felt as far away as the shores of Europe, influencing weather patterns and contributing to milder winters. Can you visualize the journey of this warm water as it crosses the ocean, gently nudging the air above it to create a ripple effect on climate? The impacts of the Coriolis effect extend beyond the mere direction of currents. They also play a critical role in the formation of gyres, large systems of circulating ocean currents. In the northern hemisphere, these gyres rotate clockwise, while in the southern hemisphere, they spin counterclockwise. This rotation creates notable patterns, with warm water accumulating in the center and cooler water drawn in from the periphery. Picture a whirlpool in a serene lake, with water swirling around a central point. This visual encapsulates the beauty and complexity of ocean gyres, each one a miniature ecosystem that harbors diverse marine life. As we explore the nuances of the Coriolis effect, it becomes clear that its influence is not uniform across the globe. The interplay of land masses, ocean basins, and the Earth's rotation creates a mosaic of current behavior. For instance, the Indian Ocean exhibits a unique response to the Coriolis effect, particularly during monsoon seasons. As winds shift, they guide the currents in a way that reflects the intricate balance of forces at play. Can you imagine the intricate choreography of wind and water, moving in harmony to create a dynamic environment that changes with the seasons? Case studies of currents affected by the Coriolis effect illustrate its significance vividly. Take, for example, the California Current, which flows southward along the coast of North America. As it travels, the Coriolis effect causes it to veer offshore, creating upwelling zones that bring nutrient-rich water to the surface. This upwelling supports vibrant marine ecosystems, teeming with life. Think of the rich tapestry of fish and marine mammals that thrive in these waters, their existence intertwined with the currents that feed them. Similarly, the Antarctic Circumpolar Current is a magnificent example of how the Coriolis effect shapes oceanic movements. It is the only current that flows completely around the globe, unfettered by land. This current is driven by the relentless westerly winds and is a vital contributor to global climate regulation. As it carries cold water from the Antarctic northward, it plays a crucial role in regulating temperatures and influencing weather patterns across the southern hemisphere. Can you envision the icy waters flowing freely, connecting distant shores and climates into a single, unified system? The Coriolis effect also influences atmospheric currents, intertwining the realms of ocean and air. As warm air rises and cooler air moves in to replace it, the rotation of the Earth causes these air masses to spiral. This spiraling motion is evident in the formation of cyclones and anticyclones, weather systems that can have dramatic effects on the climate. When we observe a hurricane forming in the tropics, it's almost as if nature itself is putting on a spectacular show, driven by the unseen forces of the Coriolis effect. As we reflect on the significance of the Coriolis effect, it becomes evident that it is more than just a scientific concept. It is a fundamental aspect of our planet's intricate systems. It connects the movement of water and air, shaping climates and ecosystems across the globe. The beauty of this phenomenon lies in its ability to reveal the interconnectedness of our world. Each current, each breeze, is a part of a larger story, a narrative written in the language of physics and nature. In the grand tapestry of ocean currents, the Coriolis effect stands as a testament to the elegance of Earth's design. It serves as a reminder of how the simplest forces can create the most complex outcomes. As we continue to explore the wonders of our oceans, let us carry with us the understanding that these currents are not mere flows of water. They are the lifeblood of our planet, a testament to the intricate dance of forces that define our world. As we explore further into the rich interplay between the Coriolis effect and ocean currents, it's essential to recognize that the Earth's rotation not only influences the currents, but also creates a myriad of ecological niches across different regions. The contrasting behaviors of currents in the northern and southern hemispheres reveal much about the delicate balance of our planet's systems. Imagine standing at the equator, where the sun's rays beat down relentlessly, warming the surface waters. This energy initiates a complex interaction with the winds, which drive the currents that will soon be subject to the Coriolis effect. The Gulf Stream, which we previously touched upon, serves as a striking example of this process. As it makes its way northward, it not only brings warmth to the chilly shores of Europe, but also interacts with the prevailing winds, creating a feedback loop that alters weather patterns and marine ecosystems. The Coriolis effect introduces a twist to the path of currents, resulting in a spiral pattern that is essential for the functioning of ocean gyres. These gyres play a critical role in climate regulation and marine biodiversity. Picture the North Atlantic gyre, with its interconnected currents working tirelessly to transport nutrients and organic materials across vast distances. The interplay of warm and cold water within these gyres fosters a diverse range of marine life, from the tiniest plankton to the largest whales. One might wonder how such a phenomenon affects life beneath the waves. The upwelling zones created by the displacement of currents, such as those influenced by the California current, are hotspots of productivity. In these areas, nutrient-rich waters rise from the deep, fueling the growth of phytoplankton, which form the base of the oceanic food web. Can you envision the intricate connections within this web, where each organism relies on the currents to bring sustenance and life? As we turn our attention to the southern hemisphere, the Antarctic circumpolar current offers a different perspective on the Coriolis effect. This mighty current encircles Antarctica, unimpeded by land, creating a unique environment. It serves to isolate the frigid Antarctic waters, effectively keeping them in a separate loop. In this way, it plays a pivotal role in regulating the temperatures of the Southern Ocean. As it flows, it interacts with the winds in a manner that amplifies its strength, contributing to the overall dynamism of the global ocean system. Can you imagine the sheer power of this current as it propels cold water across vast stretches of ocean, influencing climates far beyond its immediate reach? The significance of the Coriolis effect extends into the realm of weather phenomena as well. The origin of cyclones and hurricanes is intricately linked to the rotation of the Earth. These powerful storms are born from warm, moist air rising and being replaced by cooler air, creating a spiraling motion that is magnified by the Coriolis effect. As the warm air ascends, it cools, condensing to form clouds and precipitation. The spiral nature of these storms, a direct result of the Coriolis effect, can be visualized as a magnificent spiral shell, delicate yet formidable, swirling with energy. Renowned meteorologist Edward Lawrence once remarked, "Weather is what you expect, climate is what you get." This statement encapsulates the idea that while we can predict certain weather patterns, the underlying forces, like the Coriolis effect, create the more significant, long-term climate systems we rely on. Each storm, each current, and each breeze are threads in a complex fabric that weaves the reality of our climate. In examining the Coriolis effect, we find ourselves at the intersection of oceanography and meteorology, where the two realms influence one another in profound ways. The currents shaped by the Coriolis effect not only transport heat and nutrients, but also dictate weather patterns that can have cascading effects on ecosystems and human activities alike. The interplay of these forces is a dance of nature, illustrating how interconnected our world truly is. As we delve deeper into the case studies of various currents, we come to appreciate the nuances of the Coriolis effect. The Brazil current, flowing along the coast of South America, demonstrates how the warm waters of the tropics interact with colder waters from the Southern Ocean. This interaction creates a dynamic system where nutrient transport is vital for the rich marine life that calls these waters home. Picture the vibrant colors of fish darting among coral reefs, all thriving because of the continuous flow of water that nourishes them. Moreover, the equatorial countercurrent provides an intriguing study of how the Coriolis effect can create unexpected results. While the trade winds push surface waters westward, the Coriolis effect causes a return flow of water that moves eastward along the equator. This countercurrent is a hidden thread in the broader oceanic tapestry, subtly influencing local climates and marine ecosystems. Can you imagine the gentle ebb and flow of this current, quietly working to balance the forces at play in the ocean? As we reflect on these currents and their relationship with the Coriolis effect, it becomes clear that they are more than mere movements of water. They are vital arteries of our planet, shaping the environments in which countless species thrive. The interconnectedness of these systems highlights the delicate balance of nature and the importance of understanding the forces that govern our world. Each current, each shift, is a reminder of the intricate design of Earth, a design that continues to inspire awe and curiosity, urging us to explore the wonders that lie beneath the surface. Chapter 4: Temperature Differences, the Engine of Currents. Temperature is an invisible hand that shapes the ocean's currents, creating a dynamic interplay of warmth and coolness that drives the vast waters of our planet. As the sun bathes the Earth in its golden rays, temperature variations arise, leading to differences in the density of seawater. Warm water, lighter and more buoyant, rises to the surface, while colder, denser water sinks. This simple yet profound principle of density is the foundation upon which ocean currents are built. Can you imagine this continuous cycle, where warmer waters embrace the sky while cooler waters greet the depths below? This dance of temperature and density is further amplified by the process known as thermohaline circulation. Often referred to as the global conveyor belt, thermohaline circulation is driven by variations in temperature and salinity across the world's oceans. As seawater freezes at the poles, it leaves behind salt, increasing the salinity of the surrounding water. This denser, saltier water sinks, creating deep ocean currents that travel across the globe. Meanwhile, warmer waters, enriched with nutrients from the sun, rise and flow towards the poles, completing a vast circulation loop. Imagine the ocean as a great, living organism, its currents pulsing in rhythm with the heartbeat of the Earth. This narrative of movement is not merely a local phenomenon, but a global one. It connects distant shores and influences climates far from the point of origin. Renowned oceanographer Sylvia Earle once said, "The ocean is a world that is still largely unexplored, and it is home to incredible creatures that can teach us so much. Indeed, the currents that flow through the ocean are the silent teachers of our planet, revealing the interconnectedness of marine ecosystems and the influence of temperature on their health and diversity. The equatorial regions, with their warm embrace from the sun, serve as the heart of this thermal engine. Here, the sun's rays strike directly, heating the surface water and creating a warm, buoyant layer that sits atop the cooler depths. This warmth generates a series of currents that flow westward, giving rise to phenomena such as the Pacific Equatorial Current. These currents are critical not only for the movement of water, but also for the distribution of nutrients, which are essential for sustaining marine life. As the warm waters travel, they begin to encounter cooler regions, particularly towards the poles. In these polar areas, the temperature drops significantly, leading to a stark contrast. The cold waters, laden with nutrients from melting ice and rich in marine life, sink beneath the warmer layers. This interaction between warm and cold waters forms the foundation of upwelling currents, which bring vital nutrients to the surface, nurturing entire ecosystems. Can you picture the thriving marine life that flourishes in these nutrient-rich waters? A testament to the impact of temperature differences on biological diversity. The role of temperature extends beyond the physical movement of water. It profoundly influences marine ecosystems. Coral reefs, often referred to as the rainforests of the ocean, are particularly sensitive to temperature changes. They thrive in warm, clear waters, yet even slight increases in temperature can lead to coral bleaching, a distressing phenomenon that occurs when corals expel the algae living symbiotically within their tissues. This not only endangers the corals, but also disrupts the entire ecosystem that relies on them for shelter and sustenance. As we explore these temperature-driven currents further, it is essential to consider the role of human activity in shaping these natural processes. Climate change, driven by the increasing temperatures of our atmosphere, has cascading effects on ocean temperatures. Warmer oceans lead to altered currents, which can result in unpredictable weather patterns and shifts in marine habitats. Imagine the delicate balance of life in the ocean, now threatened by the very changes we have instigated on land. The cold, icy waters of the polar regions act as a stark reminder of the delicate equilibrium maintained by temperature variations. As the Arctic ice melts at an alarming rate, the influx of fresh water alters the salinity and density of surrounding waters, disrupting established currents and threatening the intricate balance of marine ecosystems. The impacts are felt not just in the polar regions, but ripple across the globe, affecting weather patterns, sea levels, and biodiversity. In this vast ocean of change, the stories of remarkable individuals emerge, illuminating the critical role of temperature in our marine environments. Oceanographer and climate scientist John Steele once remarked, "The ocean is a complex system, and understanding it demands interdisciplinary approaches." His insights beckon us to explore the interconnectedness of temperature, currents, and ecosystems, urging us to think holistically about our oceanic world. As we consider the significance of temperature differences in ocean currents, it becomes clear that these fluctuations serve as an engine driving not just water movement, but the very fabric of marine life. The currents, fueled by the sun's warmth and the chill of polar waters, are vital in transporting nutrients, influencing weather patterns, and maintaining the delicate balance of ecosystems. Imagine how these unseen highways of water connect distant shores and sustain the vibrant tapestry of life beneath the waves. In our quest to understand this intricate system, we must also reflect on our role as stewards of the ocean. The health of marine ecosystems is inextricably linked to the temperature of the waters they inhabit. As temperatures rise, we must ask ourselves, How can we protect these precious environments? The answer may lie in a greater awareness of our impact on the planet and a commitment to preserving the delicate equilibrium that sustains life in the oceans. The ocean currents, driven by temperature differences, are not merely natural phenomena, they are the lifeblood of our planet. They connect continents, temper climates, and nurture ecosystems, embodying the intricate balance of life. As we continue on this journey through the ocean's depths, let us remain mindful of the power of temperature in shaping this world, for it is a story of survival, resilience, and interconnectedness that resonates across the tides. The process of thermohaline circulation, while fascinating in its complexity, also underscores the fragility of the ocean's currents. As warm water rises and cold water sinks, the balance of temperature and salinity creates a vast network of movement that influences climate patterns worldwide. This global conveyor belt is a powerful reminder of how interconnected our planet's systems truly are. Have you ever wondered how the energy from the sun can travel thousands of miles, influencing ecosystems and weather far beyond its initial impact? In the equatorial regions, sunlight creates a warm layer of water that acts almost like a blanket, trapping heat and initiating currents that flow toward the poles. These currents, like the Gulf Stream, carry warmth across oceans, transforming temperate climates into something surprisingly mild. Imagine standing on the shores of a city that basks in a climate shaped by these warm waters, where palm trees sway gently in the breeze, nourished by the unseen currents that flow beneath the surface. Contrast this with the polar regions, where the story changes dramatically. Here, the sun's rays are more oblique and the waters are frigid, laden with ice. The stark temperature differences create a powerful engine driving the thermohaline circulation. As ice melts and freshwater enters the ocean, it alters salinity levels, leading to the formation of deepwater currents that are essential for nutrient distribution. These currents, often called deep ocean currents, move slowly but with a purpose, acting as a conveyor of life, transporting nutrients to regions where marine creatures thrive. As the currents travel, they encounter geographical features like continents and underwater mountains that further influence their paths. The contours of the ocean floor can redirect currents, creating upwellings that bring nutrient-rich waters to the surface. This phenomenon is evident along coastlines where vibrant ecosystems flourish, teeming with life. Can you envision the abundance of marine life that thrives in these areas, drawn by the richness of the waters? The interplay between temperature and ecosystem health is profound. For instance, phytoplankton, the foundation of the oceanic food web, relies on the nutrients brought to the surface by these currents. They flourish in regions where cold, nutrient-rich water rises to meet warm surface currents. As the sun warms the ocean's surface, phytoplankton bloom, initiating a cascade of life that supports everything from tiny fish to massive whales. These blooms are not just beautiful. They are essential for the health of our planet, producing a significant portion of the oxygen we breathe. Yet, as we marvel at these processes, we cannot ignore the impact of human activity on temperature and, consequently, on ocean currents and ecosystems. The rise of atmospheric temperatures due to greenhouse gas emissions is leading to warmer oceans, which can disrupt the delicate balance of thermohaline circulation. Changes in currents can result in altered weather patterns, with potential consequences for agriculture, fisheries, and global climate stability. Consider the implications of these shifts. The once reliable patterns of currents that have existed for millennia are now in flux. This unpredictability can lead to extreme weather events affecting communities far from the ocean's edge. Think about the ripple effects. A change in ocean temperature can influence rainfall in distant regions, affecting food security and livelihoods. As we navigate this complex landscape, the stories of those who dedicate their lives to understanding these changes come to light. Marine biologist Sylvia Earle, a pioneer in ocean exploration, has stated, "We are the ocean. We are the sea." Her words remind us that the health of our oceans is intrinsically linked to our own well-being. Her work emphasizes the importance of conserving marine ecosystems that are vulnerable to temperature fluctuations and the resulting currents. In addition to the physical changes, we must also recognize the emotional connection we have with the ocean. The mysteries that lie beneath the waves evoke a sense of wonder and tranquility. As we ponder the vastness of the sea, we are reminded of our place in this intricate web of life. How can we foster a deeper respect for the ocean and its currents? Each action we take, no matter how small, contributes to the larger narrative of ocean health. By reducing our carbon footprint and advocating for sustainable practices, we can help ensure that the temperature balance is maintained, allowing currents to flow harmoniously and ecosystems to thrive. In the ongoing story of our oceans, the temperature differences that drive currents are a testament to the resilience of nature. They remind us that while the forces of change can be overwhelming, the potential for recovery and regeneration exists. Our oceans have the capacity to heal, but it requires a collective effort to protect and cherish these vital waters. As we continue our exploration, let us remain ever mindful of the profound impact temperature has on the currents that shape our world. These currents are not mere movements of water. They are the lifeblood of our planet, weaving together the fabric of marine ecosystems and influencing life on land. With each wave that laps against the shore, we are reminded of our responsibility to care for this great expanse, to ensure that the currents continue to flow, nurturing life for generations to come. Chapter 5: Salinity and its influence on ocean currents. Salinity is a measure of the concentration of salts dissolved in seawater, primarily sodium chloride, along with various other minerals and trace elements. It is a critical property of ocean water, influencing not only the chemical makeup of marine ecosystems, but also the physical dynamics of ocean currents. Salinity is typically expressed in parts per thousand, a reflection of the mass of salt per unit of water. Imagine standing on the shore, where the ocean meets the land, and feeling the briny taste of seawater on your lips. This taste is a reminder of the myriad minerals swirling beneath the surface, shaping the life that thrives in the depths. Variations in salinity are not uniform across the globe. Factors such as evaporation, precipitation, river inflow, and melting ice all contribute to the intricate patterns of salinity found in the oceans. For instance, in regions where evaporation exceeds precipitation, like the Mediterranean Sea, salinity levels can rise significantly. Conversely, in places where rivers pour fresh water into the sea, like the Amazon River, salinity drops sharply. Imagine the delicate balance of these forces, where the ocean's surface becomes a tapestry of varying salinity levels, each influencing the water's density and, in turn, its movement. Water density is a crucial aspect of the ocean's behavior. As salinity increases, the density of seawater rises. This principle becomes particularly important when examining how salinity interacts with temperature, the other significant player in determining water density. Warm water is lighter and less dense than cold water, creating a layered structure within the ocean. When combined with variations in salinity, the result is a complex system of stratification. Picture a glass filled with layers of different liquids, each varying in density, refusing to mix. This stratification is what occurs in the oceans, where lighter, fresher waters float above denser, saltier waters. The interaction between salinity and temperature is vital for understanding ocean currents. When warm, salty water combines with cooler, fresher water, the resulting changes in density can lead to the creation of currents. For example, in the North Atlantic, warm water from the Gulf Stream meets colder waters from the Arctic. This interaction is not merely a meeting of temperatures. It is a dynamic exchange that drives a significant part of global ocean circulation. Imagine the Gulf Stream as a warm embrace, gently flowing towards the north, while the cooler waters from the poles, heavy with salt, descend into the depths, creating a cycle of movement that influences climate and weather patterns far beyond the ocean itself. The importance of salinity is further highlighted by the phenomenon known as thermohaline circulation. This vast, global conveyor belt of ocean currents is driven by the combined effects of temperature and salinity, as previously discussed. As cold, saline water sinks in the polar regions, it generates a flow that pulls warmer water from the equator toward the poles. As this warmer water cools and loses some of its buoyancy, it ultimately returns to the depths, completing a global circuit. Visualize this movement as a heartbeat of the ocean, rhythmically pumping warm water northward and cold water southward, influencing not just marine life, but also the climate of entire continents. Consider the Gulf Stream once more. It is not just a current, it is a lifeline that shapes the climates of North America and Europe. As it flows, it carries with it not only heat, but also varying salinity levels influenced by its journey across vast expanses of ocean. This current plays a crucial role in the moderation of temperatures, allowing for milder winters in parts of Europe and impacting weather patterns across the Atlantic. Here, salinity is not merely a measurement. It is an active participant in the drama of climate and weather. Another remarkable example of salinity influencing ocean currents can be found in the Antarctic Circumpolar Current. This current encircles Antarctica, driven by the unique salinity and temperature characteristics of the surrounding waters. As icebergs calve and melt, they introduce fresh water into the salty ocean, creating a gradient that affects the current's behavior. Imagine this current as a giant river flowing ceaselessly around a continent, its path shaped by the interplay of salinity and temperature. The Antarctic Circumpolar Current is not just a geographical feature. It plays an essential role in regulating heat distribution across the globe, acting as a barrier that separates cold polar waters from the warmer waters of the Atlantic and Pacific. Salinity variations also determine the health of marine ecosystems. In estuaries, where fresh river water meets saltwater from the ocean, salinity levels fluctuate dramatically with the tides and seasons. These changes create unique habitats that support diverse marine life. Picture the resilience of species that thrive in this brackish environment, perfectly adapted to the dance between fresh and saltwater. The delicate balance of salinity in these areas is crucial for the survival of fish, crustaceans, and numerous other organisms. Changes in salinity can disrupt this balance, leading to shifts in biodiversity and ecosystem health. The work of scientists such as Sylvia Earle highlights the importance of understanding salinity in the context of broader ocean health. Earle has often stated that the ocean is our life support system, a powerful reminder of the interconnectedness of all life on Earth. As we explore the depths and dynamics of our oceans, we are reminded of the intricate web of relationships that salinity plays a central role in shaping. It is a testament to the complexity of marine environments, as well as to the resilience of the life forms that inhabit them. Salinity does not merely influence ocean currents. It also affects weather patterns and climate on a broader scale. The exchange of heat and moisture between the ocean and atmosphere is mediated by these currents, which transport warm water to cooler regions. This redistribution of heat can lead to the development of storms and weather systems. Imagine the warm, moist air rising from the ocean's surface, swirling into the atmosphere to form clouds that eventually release their bounty as rain. This cycle is intricately tied to the salinity of ocean waters, which influences how much heat is absorbed and released into the atmosphere. One cannot overlook the human impact on salinity levels in the oceans. Activities such as agriculture, urban development, and industrial processes can lead to increased runoff of fresh water and pollutants into the sea. These changes can alter salinity patterns, with potential consequences for marine life and ocean currents. Consider the plight of coastal ecosystems struggling to adapt to these rapid shifts. The delicate balance of salinity that once supported vibrant habitats is now threatened, leading to questions about the future of our oceans and the species that depend on them. In exploring the relationship between salinity and ocean currents, we uncover a beautiful complexity that extends beyond mere numbers. The ocean, with its vast and varied salinity, serves as a reminder of the delicate equilibrium that sustains life on our planet. Each current is a story, a movement defined by the interplay of water and salt, warmth and cold, life and the environment. As we continue to delve into the mysteries of the ocean, let us remember the significance of salinity, not just as a scientific measure, but as a crucial element in the intricate and ever-evolving narrative of our blue planet. In addition to the physical dynamics of currents, salinity plays a pivotal role in influencing marine life. The unique adaptations of organisms in varying salinity levels highlight the remarkable resilience of life. For instance, estuarine species, such as the American eel, thrive in environments where saltwater and freshwater intermingle. These creatures demonstrate adaptability, adjusting their physiology to survive in the fluctuating salinity levels that characterize estuaries. Imagine these eels, gliding through brackish waters, their bodies finely tuned to the ebb and flow of salinity, showcasing nature's ability to endure and evolve. Moreover, the impact of salinity extends beyond individual species to entire ecosystems. Coral reefs, often referred to as the rainforests of the ocean, depend heavily on stable salinity levels. Changes in salinity can stress coral polyps, leading to bleaching events where corals expel the symbiotic algae that provide them with nutrients and color. Picture the vibrant colors of a healthy reef, alive with the hues of countless organisms. Now envision this vivid palette fading as salinity fluctuations disturb the delicate balance of life. The health of these ecosystems is inextricably linked to the broader patterns of salinity influenced by ocean currents. As we ponder the significance of salinity, it is essential to consider the role of salinity in climate phenomena. The El Niño and La Niña events are prime examples of how shifting salinity and temperature patterns can lead to extensive climate changes. During an El Niño event, warmer waters in the eastern Pacific Ocean disrupt the usual patterns of salinity and temperature, resulting in widespread weather anomalies across the globe. Imagine the profound effects of this disruption as storm patterns shift and rainfall becomes erratic, impacting agriculture and water supplies. Conversely, La Niña events bring cooler waters and can lead to increased salinity in certain areas, further complicating the global climate narrative. The interplay of salinity and currents is vividly illustrated in the Indian Ocean, where the monsoon winds dictate both temperature and salinity levels. As the monsoon season brings heavy rains, fresh water dilutes the salty ocean, altering the density and flow of currents. Picture the vast Indian Ocean, where seasonal shifts create a dynamic environment that supports diverse marine life, from vibrant coral reefs to bustling fisheries. The delicate balance of salinity here can influence everything from local ecosystems to the livelihoods of coastal communities. Remarkable individuals in oceanography have dedicated their lives to studying the intricate relationships among salinity, currents, and climate. One such pioneer is Walter Munk, often hailed as the Einstein of the oceans. Munk's groundbreaking research has shed light on the connections between ocean currents and climate, emphasizing the importance of understanding salinity as part of this equation. He once remarked on the ocean's complexity, emphasizing that it is not merely a body of water, but a living, breathing entity that requires our respect and understanding. As we explore further, it becomes apparent that salinity's influence reaches into the depths of the ocean as well. Below the surface, in the abyssal zones, salinity can vary significantly due to factors such as deep-sea currents and geothermal activity. These variations create microhabitats, where unique species have evolved to thrive under extreme conditions. Imagine the dark, cold waters inhabited by bioluminescent creatures, their existence a testament to the adaptability of life in the face of salinity changes. The mechanisms of salinity and currents also intersect with human activities, leading to profound implications. Desalination plants, designed to convert seawater into fresh water, have gained prominence in regions facing water scarcity. However, the process of removing salt from seawater can inadvertently alter local salinity levels, affecting nearby marine ecosystems. Consider the balance between human necessity and environmental stewardship as we draw from the ocean's vast resources. The challenge lies in ensuring that our actions do not disrupt the delicate dance of life supported by salinity and currents. As we contemplate the intricate web of relationships formed by salinity and ocean currents, we come to appreciate the ocean's role as a vital system that nurtures life on Earth. Each fluctuation in salinity, each current created, is a thread in the fabric of a global network that influences everything from weather patterns to the health of marine organisms. The ocean, in all its complexity, invites us to understand and cherish the delicate balance that sustains it. Thus, as we proceed through this chapter, let us remain mindful of the interconnectedness of all these elements. Salinity is not merely a measure. It is a vital force that shapes our oceans and, by extension, our planet. The currents that flow through the sea tell a story of life, resilience, and the intricate dance of nature, one that we are all a part of, whether we stand on the shore, dip our toes in the water, or simply gaze at the horizon. Chapter 6: The Impact of Earth's Topography on Currents. The ocean basin is a vast and intricate realm, marked by features that play critical roles in shaping the currents that flow through its waters. Imagine the ocean floor as a complex landscape, where underwater mountains rise like silent giants, valleys carve deep into the earth, and vast plains stretch endlessly beneath the waves. Each of these features influences how water moves, creating a grand symphony of currents that reverberate throughout the oceans. The continental shelf, the submerged extension of a continent, is a significant player in this orchestration. It acts like a gentle ramp, gradually sloping from the coastline into deeper waters. This gradual incline allows currents to flow in more predictable patterns. The presence of underwater ridges and mountains disrupts the smooth flow of water, forming eddies and currents that can redirect the movement of seawater. Picture how a stone alters the surface of a stream, creating ripples that expand outward. Similarly, these topographic features can enhance or diminish the energy of ocean currents, affecting everything from marine navigation to climate patterns. One notable example of this influence is the Agulhas Current, which flows along the southeast coast of Africa. This powerful current is shaped by the contour of the continental shelf and the underlying topography of the ocean floor. As it travels southward, it encounters the steep drop-off of the continental shelf, which accelerates its flow and creates turbulence. This dynamic interaction not only affects the current itself, but also influences weather patterns along the coast, illustrating how profoundly topography can impact oceanic movements. Ocean currents do more than just flow. They are agents of change in the coastal environment. The relentless push and pull of moving water shape coastlines, constantly eroding and depositing sediment. Coastal erosion is a natural process, yet it can be accelerated by the strength and direction of ocean currents, particularly where continental shelves meet steep drops. Can you envision the grains of sand, sculpted by the ebb and flow of water, gradually being carried away by powerful currents? As sediment is transported, it can alter the very shape of coastlines, creating new landforms and habitats along the way. The Mississippi River, for instance, carries vast amounts of sediment into the Gulf of Mexico, where the interplay of riverine and ocean currents creates a unique estuarine environment. Here, sediment is deposited, forming deltas that serve as critical habitats for countless species. The delicate balance between erosion and deposition highlights the interconnectedness of ocean currents and coastal ecosystems, where each current acts as a brushstroke on the canvas of the shoreline. Examining specific case studies reveals further insights into the impact of topography on ocean currents. The California Current, a cold ocean current that flows southward along the western coast of North America, is greatly influenced by the region's geographical features. The coastal mountains and valleys create a funneling effect, channeling winds that enhance the current's flow. This interaction not only contributes to the current's temperature profile, but also affects the rich marine life supported by the nutrient upwellings associated with it. Imagine the vibrant marine ecosystem thriving in the cold, nutrient-rich waters brought up by the currents. Species such as sardines, anchovies, and various types of plankton flourish in these conditions. The productivity of this region is a direct result of the topographic interplay between the ocean floor and the coastal landscape, showcasing how the physical features of the Earth shape not only the currents, but also the life they sustain. In the Southern Ocean, the Antarctic circumpolar current flows unimpeded around the continent of Antarctica, driven by the unique topography of the ocean basin. Here, the vast expanse of the ocean is interrupted only by the landmass of Antarctica itself. This current is significant as it connects the Atlantic, Pacific, and Indian Oceans, creating a continuous loop that plays a vital role in global climate regulation. The interaction between this powerful current and the surrounding topography influences the distribution of heat and nutrients in the ocean, showcasing how topography can dictate the flow of currents on a global scale. Further, the impact of underwater ridges can be observed in the North Atlantic, where the Mid-Atlantic Ridge runs through the ocean. This ridge not only acts as a barrier to currents, but also influences the temperature and salinity of the surrounding waters. These characteristics, in turn, affect the Gulf Stream, which flows from the Gulf of Mexico along the eastern United States and across the Atlantic. The warmth of the Gulf Stream is, in part, a consequence of the ocean floor's configuration, demonstrating how the depth and structure of the seabed impact water movement and temperature distribution. The interplay of currents and topography extends beyond mere physical movement. It is a crucial component of the Earth's climate system. The currents act as conduits for heat, transporting warm water from the equator toward the poles, while cooler waters flow back toward the equator, maintaining a delicate balance. This constant exchange is vital for regulating temperatures across different regions of the globe. As we contemplate the ocean's currents and the topographical features that shape them, we can appreciate the profound connections that exist within this system. Each ridge, valley, and shelf contributes to a larger narrative, one where the forces of nature work in concert to create the ever-changing landscape of our oceans. The beauty of this relationship lies in its complexity and its harmony, where every element plays its part in the grand orchestration of the marine world. Understanding these dynamics invites a sense of wonder. Can you visualize the ways in which the ocean floor interacts with the currents above, creating patterns that ripple through both water and air? Each current, influenced by the topography beneath, tells a story of movement, change, and transformation. The ocean is not just a body of water. It is a living entity, shaped by the Earth's contours, breathing life into the ecosystems it supports and influencing the climates of the lands that touch its shores. As we reflect on these intricate relationships between the ocean's topography and its currents, we come to appreciate the subtle yet profound impacts these features have on our planet. Each current is a testament to the geological history of our Earth, shaped by forces that have been at work for eons. The interplay of land and sea, of elevation and depth, continues to sculpt our world, revealing the beauty and complexity of nature's design. The intricate features of the ocean basin not only shape currents, but also serve as conduits for energy and nutrients, fostering the marine ecosystems that thrive within their embrace. Consider how the ocean floor's contours, from the gentle rise of the continental shelf to the steep cliffs of underwater mountains, create a dynamic landscape that influences everything from water movement to biological richness. Continental shelves, in particular, are intriguing because they provide a unique environment where sunlight can penetrate deeper, allowing photosynthetic life to flourish. This productivity supports an array of marine species, forming the foundation of food webs that sustain life in the ocean. These shallow waters are often bustling with activity, teeming with life, as phytoplankton bloom in response to the nutrients stirred up by currents. Imagine the vibrant colors of these microscopic plants, their growth igniting the waters with life, drawing in small fish that, in turn, attract larger predators. Underwater ridges, such as the Mid-Atlantic Ridge, further contribute to the complexity of ocean currents. These geological formations not only act as barriers, but also create areas of upwelling, where nutrient-rich waters rise from the depths to the surface. Upwelling zones are essential for supporting marine life, as they bring essential nutrients to areas where sunlight can fuel the growth of phytoplankton. The chain reaction that follows is profound. More phytoplankton means more small fish, which in turn supports larger species, illustrating how topography can enhance biological productivity in the ocean. The interaction of currents with the ocean floor extends its influence beyond just biological systems. It plays a crucial role in coastal erosion and sediment transport, shaping coastlines over time. As currents collide with land, they exert force that can erode rock and sediment, carrying these particles away and redistributing them along the shore. This process can be vividly imagined, with waves crashing against cliffs, wearing them down like time slowly erodes a stone statue. Over time, this relentless force can lead to dramatic changes in coastal landscapes, leading to the formation of beaches, dunes, and estuaries. One fascinating aspect of sediment transport is how particular currents can alter the very geography of coastlines. For example, the longshore current, driven by waves hitting the shoreline at an angle, moves sand and sediment parallel to the coast. Picture this current as a natural conveyor belt, transporting grains of sand along the beach, reshaping the shoreline with each passing tide. The constant movement of sediment can create new habitats and alter existing ones, emphasizing the intricate relationship between ocean currents and coastal ecosystems. In regions like the Gulf of Mexico, the interplay of river systems and ocean currents creates unique environments. The Mississippi River, flowing into the Gulf, is a significant source of freshwater and sediment, contributing to the rich estuarine ecosystems found there. As the river meets the salty waters of the Gulf, a dynamic interaction occurs, leading to stratification where different densities of water layer themselves. Imagine this mixing as a dance, where freshwater and saltwater swirl together, creating a productive nursery for juvenile fish and other marine life, an area where life begins anew. Examining case studies of specific currents reveals even more about the impact of topography on oceanic movements. The Brazil Current, for instance, flows northward along the coast of South America, influenced by the nearby continental shelf and the geography of the land. This warm current not only affects local weather patterns, but also plays a vital role in the larger context of ocean circulation. As it interacts with the colder waters of the South Atlantic, it helps to regulate temperatures across vast distances, illustrating how localized features can have far-reaching effects. The Bering Sea presents another compelling example. The underwater topography, including the Aleutian Islands and the Bering Strait, creates a unique environment where cold, nutrient-rich waters meet warmer currents from the Pacific Ocean. This convergence leads to one of the most productive fishing grounds in the world. Can you visualize the bustling life that thrives in these waters as currents churn and mix, creating a rich tapestry of marine biodiversity? This area is not just a testament to the power of currents, but also to the delicate balance of ecosystems that depend on these movements. The impact of ocean currents on climate cannot be understated. The currents act as a transport mechanism for heat and nutrients, influencing weather patterns and climate systems across the globe. The North Atlantic Drift, an extension of the Gulf Stream, carries warm water to northern latitudes, significantly affecting the climates of regions like Western Europe. Imagine the contrast between the icy winds of the Arctic and the temperate breezes of coastal Norway, a testament to how ocean currents shape not only the environment, but also the cultures and livelihoods of those who inhabit these regions. As we explore the relationship between topography and ocean currents, we begin to appreciate the delicate balance of forces at play. Geological features like underwater ridges and continental shelves are not merely passive landscapes. They actively shape the currents that flow above them. Each shift in the ocean floor can create ripples felt across vast distances, affecting everything from marine biodiversity to coastal erosion and climate regulation. In contemplating this interplay, one cannot help but wonder about the future of these ecosystems in the face of climate change. How will rising temperatures and shifting currents alter the intricate relationships between ocean features and marine life? The answers may lie in the very currents themselves, as they adapt and evolve in response to the changing world around them. This ongoing dance of water, land, and life invites us to look deeper into the ocean's mysteries. The currents, driven by the Earth's topography, tell a story of interconnection and transformation, revealing the profound impacts these features have on the world we inhabit. Each wave, each current, is a reminder of the dynamic nature of our planet, where every element plays a role in the continuous cycle of change. Chapter 7: Seasonal Changes and Their Effects on Currents. As the seasons shift, a gentle transformation envelops the world, subtly influencing both wind patterns and ocean currents. Each season brings with it a unique character, a distinct rhythm that reverberates through the atmosphere and the waters below. Imagine the warmth of summer sun coaxing the air into a gentle warmth, while winter's chill wraps the landscape in a crisp embrace. Such variations in temperature are not mere atmospheric phenomena. They profoundly affect the currents that flow through our oceans, sculpting the very fabric of marine ecosystems. The interplay between seasonal winds and temperature is intricate and vital. During summer, the sun's rays bathe certain regions in warmth, creating rising air that sets off a chain reaction. This warm air, lighter and less dense, ascends, drawing cooler air from surrounding areas to replace it. As this cycle continues, winds strengthen, flowing over the ocean's surface and creating currents that dance and swirl beneath, influenced by the warmth of the season. Conversely, in winter, as temperatures drop, air density increases, leading to a different wind pattern that can alter the strength and direction of ocean currents. Can you envision how these seasonal winds shape the very essence of our oceans, guiding the waters in a gentle embrace? As we observe the world's oceans, we can pinpoint specific currents that exemplify the profound impact of seasonal changes. The California current, for instance, flows southward along the coast of North America, carrying cool, nutrient-rich waters. However, during the summer months, upwelling occurs, bringing these nutrients to the surface, fostering a vibrant marine ecosystem teeming with life. In contrast, the warm Gulf Stream, which flows from the Gulf of Mexico along the eastern United States and across the Atlantic, exhibits changes in strength and direction with the seasons, affecting weather patterns and temperatures far beyond its reaches. Picture the warmth of the Gulf Stream extending its gentle fingers into the colder northern Atlantic, as if whispering a promise of milder winters to those who reside in its path. Another striking example can be found in the Antarctic Circumpolar Current, which encircles the continent of Antarctica. This current is not only the strongest ocean current on Earth, but it also showcases the dramatic seasonal variations that can occur. In the summer, when sunlight bathes the region, melting ice contributes fresh water to the surrounding seas, altering salinity levels and influencing the current's dynamics. As winter descends and ice forms anew, the increased salinity of the surrounding waters causes the currents to shift and strengthen, demonstrating nature's remarkable adaptability. How often do we stop to consider the intricate balance of forces that govern these mighty flows? Seasonal changes do not merely influence the currents themselves, they also carry profound ecological implications. As currents shift in response to seasonal variations, they transport nutrients essential for marine life. In the spring, as sunlight warms the waters and stimulates phytoplankton growth, the currents become vital conduits of nourishment. Marine species rely on these currents to guide them towards feeding grounds, ensuring their survival and the delicate balance of marine ecosystems. Imagine the tiny phytoplankton, the very foundation of the oceanic food web, flourishing in the sunlit waters, their abundance carried by currents to feed the hungry mouths of fish, seabirds, and mammals alike. However, these seasonal currents also play a significant role in the migratory patterns of various species. Salmon, for example, are intimately connected to the currents of their native rivers. As they journey from the ocean to their spawning grounds, they rely on the seasonal changes in river flow, driven by melting snow and rain. The currents guide them on their arduous journey, a testament to the interconnectedness of aquatic life and the rhythms of nature. Can you picture the journey of a salmon swimming against the current, determined to return to the place of its birth, driven by instinct and the seasonal shifts of its environment? Yet, the ecological implications of these currents extend beyond individual species. Coral reefs, often referred to as the rainforests of the sea, depend on the health of ocean currents for their survival. These vibrant ecosystems thrive in warm, shallow waters, and the currents that flow around them transport not only nutrients, but also larvae and other essential organisms. As seasonal changes affect water temperature and salinity, they can either nurture these reefs or pose serious threats to their existence. The delicate balance of life within these reefs is a reminder of the intricate connections that bind the marine environment together. As we continue to explore the depths of our oceans, it becomes clear that seasonal changes shape not only the currents we observe, but also the entire tapestry of life that flourishes beneath the waves. The currents are more than mere flows of water. They are lifelines that connect ecosystems, drive migration, and sustain the diverse forms of life that inhabit our oceans. Through the lens of seasons, we witness a world that is both dynamic and resilient, adapting continuously to the rhythms of nature. What if we could listen closely to the whispers of the ocean, the secrets carried by its currents? The seasonal shifts invite us to engage with the world around us, to observe the patterns that emerge as nature unfolds its narrative. Perhaps the beauty lies not only in the currents themselves, but in the stories they tell of life, of migration, and of the delicate balance that sustains our planet's oceans. As we reflect on the profound impacts of seasonal changes on ocean currents, we are reminded of the remarkable interconnectedness of the natural world. Each current, each seasonal shift, contributes to the larger symphony of life, where every note plays a role in the melody of our planet's ecosystems. With each passing season, the ocean continues to weave its intricate patterns, carrying with it the stories of countless species and the very essence of life itself. As we embrace the unfolding of the seasons, we also witness the subtle changes in ocean currents that accompany these transformations. The interplay of temperature and wind, influenced by the Earth's tilt and orbit, creates a dynamic environment. When seasons shift, the sun's path across the sky alters, casting different angles of light and warmth upon the water's surface. This variation in solar energy not only affects air temperatures, but also plays a crucial role in the heat distribution of the oceans. Can you feel the gradual warmth of spring as it nudges the chill of winter away, inviting life to emerge anew? In many regions, the transition from winter to spring heralds a significant change in current strength and direction. During this period, the melting of snow and ice feeds rivers and coastal waters, introducing fresh, cold water into the mix. This influx alters the density of the seawater, causing shifts in local currents. The phenomenon is particularly visible in the North Atlantic, where the melting ice from Greenland changes the salinity and temperature, prompting the currents to adjust their paths. This delicate balance is vital, for it sets the stage for the rich marine life that thrives in these waters. As summer approaches, the currents often gain strength, driven by the warmer temperatures and prevailing winds. The North Equatorial Current, for instance, flows westward across the Pacific Ocean, carrying warmth from the equator towards the Philippines and beyond. This current, in conjunction with the trade winds, creates an environment that supports vast migrations of marine species, from the smallest plankton to the largest whales. Imagine the vast ocean as a highway, bustling with life as currents guide these creatures on their epic journeys. In contrast, as autumn descends, the currents begin to cool and the winds shift once more. The seasonal transition can be observed in the California current, where cooler waters dominate, leading to a decrease in marine productivity. Here, marine life must adapt to the changing environment, often retreating to deeper waters where the temperature remains stable. This seasonal ebb and flow creates a rhythm that resonates throughout the oceans, shaping the behavior and distribution of species. How marvelously intricate is this dance of life, where every shift in temperature and current reverberates through the vast web of the marine ecosystem. The ecological implications of these seasonal currents stretch far beyond mere temperature changes. Nutrient cycling, driven by the shifting currents, is vital for supporting marine life. As currents weaken or change direction, they can either bring nutrients from the depths to the surface or disperse them across vast areas. During spring, for example, the upwelling of nutrient-rich waters along the coasts fosters an explosion of phytoplankton growth. These tiny organisms form the bedrock of the oceanic food web, supporting everything from small fish to the mighty blue whale. Picture the ocean brimming with life, as currents carry these essential nutrients to nourish the vibrant tapestry of marine ecosystems. Moreover, seasonal currents also dictate the migratory patterns of various species. The great bluefin tuna, known for its remarkable journeys across the Atlantic, utilizes these currents to guide its path. As it travels from spawning grounds in the Gulf of Mexico to feeding areas off the coast of Europe, it follows the currents that provide the most favorable conditions. What drives these magnificent creatures to embark on such arduous voyages? Could it be an instinctual understanding of the ocean's rhythms, woven into their very being? In the polar regions, the impact of seasonal changes on currents becomes even more pronounced. The Arctic Ocean experiences dramatic transformations with the arrival of summer ice melt, leading to increased freshwater input. This alteration in salinity profoundly impacts the currents as the balance between fresh and saltwater shifts. The consequences reverberate through the ecosystem, influencing the distribution of species like narwhals and seals, which depend on specific habitats for feeding and breeding. Can you imagine the intricate web of life that forms in response to these seasonal currents, each thread connected to the next, creating a vibrant community? Similarly, the Southern Ocean, with its unique currents, plays a crucial role in global climate regulation. The Antarctic Circumpolar Current, which encircles the continent, is instrumental in the distribution of heat and nutrients. As summer approaches, the melting of icebergs introduces fresh water, altering the current's dynamics and affecting the marine life that thrives in these waters. The delicate balance of this ecosystem is a reminder of the interconnectedness of seasonal changes and the health of our oceans. The seasonal changes in ocean currents also impact human activities, from fishing to shipping. Fishermen rely on these predictable patterns to determine the best times to harvest their catches, while vessels navigate the seas, often at the mercy of the currents that shape their journeys. Understanding the behavior of currents can be the difference between a bountiful catch and an empty net. How fascinating it is to consider the ways in which our lives are intertwined with the rhythms of the ocean, where nature's cycles dictate not only the lives of marine creatures, but also the livelihoods of those who depend on the sea. As we continue to explore the seasonal changes that shape our oceans, we uncover a world of complexity and wonder. The currents are not just lines of water flowing through the vastness of the sea. They are vital pathways of life, connecting distant ecosystems and supporting the myriad forms of life that inhabit our planet. Each season brings new opportunities and challenges, a reminder of nature's resilience and the delicate balance that sustains life beneath the waves. What stories lie within these currents, waiting to be discovered as we listen to the whispers of the ocean? Chapter 8: Human Activities Altering Ocean Currents. The ocean, a vast expanse that covers more than 70% of our planet, is delicately balanced, with currents flowing like arteries beneath its surface. As we explore how human activities impact these vital currents, we must first understand the profound interconnectedness that governs our oceans. These currents are not merely physical phenomena. They are essential to sustaining life, regulating climate, and shaping ecosystems. Yet, as humankind continues to expand its footprint, the influence on these currents has become increasingly pronounced. Human activities, whether through emissions that warm the planet or the pollution we introduce into our waters, have begun to alter the natural flow of the ocean. Climate change, driven by greenhouse gas emissions, is perhaps the most significant factor. As the planet warms, the delicate dance of temperature and salinity is disrupted, leading to changes in ocean currents that can cascade through the entire climate system. Picture the ocean as a giant engine, with temperature differences fueling its movement. When we disrupt these temperature gradients, we risk throwing the entire system out of balance. Consider the Arctic, where melting ice has caused a dramatic decrease in the salinity and temperature of the surrounding waters. As freshwater from the melting ice alters the density of seawater, the currents that once flowed steadily can become sluggish or even change course. Imagine the implications of this shift. The Gulf Stream, a current crucial to regulating climates in Europe and North America, may weaken, leading to colder winters and altered weather patterns. How might this affect agriculture, ecosystems, and human livelihoods? Pollution is another insidious force shaping our ocean currents. Plastics, chemicals, and other contaminants enter the waters, often finding their way into the currents that carry them far from their original source. This pollution not only harms marine life, but can also alter the physical properties of the water. For instance, the introduction of warm, polluted water from coastal development can change local thermal profiles, affecting how currents form and flow. Imagine a river flowing through a forest, its water clear and nourishing. Now envision it choked with debris and chemicals, struggling to maintain its course. This analogy reflects the plight of many currents affected by human actions. Coastal development presents another challenge. The construction of ports, marinas, and other structures can disrupt natural water flow, leading to increased sedimentation and altered current patterns. When natural coastlines are modified, the currents that once nurtured ecosystems can be redirected or diminished. This not only affects marine habitats, but also has implications for coastal communities that rely on the health of these ecosystems for their livelihoods. Can you envision the delicate balance that is lost when the ocean's natural rhythms are interrupted? In light of these challenges, it is vital to consider strategies to mitigate human impact on ocean currents. One promising approach is the restoration of coastal ecosystems, particularly mangroves and wetlands. These natural barriers not only provide protection against storm surges, but also play a crucial role in filtering pollutants and stabilizing sediments. Imagine a thriving mangrove forest, its roots weaving together like a protective net, allowing the currents to flow freely while filtering out harmful substances. Such restoration efforts can help to revive the natural dynamics of currents and enhance the resilience of coastal communities. Another strategy involves the reduction of greenhouse gas emissions. By transitioning to renewable energy sources and promoting sustainable practices, we can slow the pace of climate change and its effects on ocean currents. Picture a world where clean energy powers our homes and vehicles, reducing the heat that enters our atmosphere and oceans. With every small action taken toward sustainability, we contribute to a larger movement that protects the delicate balance of the ocean. International collaboration is also essential in addressing these challenges. Ocean currents do not recognize political boundaries; they flow freely across nations. Therefore, cooperative efforts to manage pollution, protect marine habitats, and combat climate change are imperative. Joint initiatives, such as marine protected areas, can safeguard important ecosystems while promoting a healthier ocean that can sustain its currents. Imagine a global community coming together to protect the oceans, ensuring that future generations can experience the beauty and bounty they offer. As we reflect on the myriad ways human activities are altering ocean currents, we must remember that the ocean is not just a vast body of water. It is a living entity that requires our stewardship. By embracing sustainable practices and fostering a sense of responsibility for our oceans, we can help restore the balance that has been disrupted. Each step we take can contribute to a more harmonious relationship with the natural world, allowing the currents to flow as they were intended, nourishing life and shaping our climate for generations to come. As we reflect on the intricate interplay between human activities and ocean currents, it becomes clear that the effects of climate change extend beyond mere temperature fluctuations. The warming of the planet is leading to shifts in ocean stratification, a process where layers of water become distinctly separated based on temperature and salinity. Imagine a layered cake where each layer has its unique flavor. When these layers mix, they create a rich blend, but if they remain isolated, the result is a less dynamic ecosystem. The stratification of the ocean can impede the upwelling of nutrient-rich waters from the depths, ultimately affecting the productivity of marine life. The implications are profound, as reduced productivity can lead to diminished fish populations and further impact coastal communities reliant on these resources. How does this phenomenon play out in the broader context of ocean health? When the ocean's surface warms, it creates a barrier that inhibits the mixing of waters. This can lead to areas of low oxygen, often referred to as dead zones, where marine life struggles to survive. Such regions are becoming increasingly common, with scientists documenting a troubling increase in their frequency and size. Can you picture the once vibrant underwater landscapes now eerily quiet, devoid of the bustling life that once thrived there? Pollution, particularly nutrient runoff from agricultural practices, exacerbates this issue. Excessive fertilizers wash into rivers and eventually into the ocean, leading to harmful algal blooms that further deplete oxygen levels. These blooms can create a toxic environment, not only choking out marine life, but also impacting human health and coastal economies. The words of an environmentalist resonate here. Protecting marine ecosystems is not just about preserving beauty. It is about safeguarding the very fabric of life that sustains us all. Additionally, coastal development has far-reaching implications for ocean currents. The construction of artificial barriers, such as seawalls and jetties, can alter natural currents and sediment transport processes. Imagine a river's flow being redirected by a dam, leading to consequences that ripple downstream. Similarly, when coastal infrastructure disrupts the natural flow of water, it can lead to beach erosion, habitat loss, and changes in water quality. Such developments often prioritize short-term economic gain over long-term ecological stability. In response to these pressing challenges, what can be done to mitigate the impact of human activities on ocean currents? One approach lies in rethinking coastal management. Sustainable development practices that prioritize environmental health can help minimize disruption to natural currents. By restoring mangroves and wetlands, we can enhance coastal resilience and improve water quality. Picture a thriving coastal ecosystem, where the roots of mangrove trees anchor the soil, providing shelter for countless marine species while filtering pollutants before they reach the open ocean. Education and awareness also play vital roles in fostering a deeper understanding of our oceans and their currents. By empowering communities to engage in conservation efforts, we can cultivate a sense of stewardship that resonates across generations. Imagine a world where children grow up with a profound appreciation for the ocean, understanding its rhythms and the importance of preserving its delicate balance. International policies and agreements are essential components in addressing the global nature of ocean currents. Collaborative efforts to monitor and protect marine environments can foster a shared responsibility among nations. Consider the potential of countries coming together to create marine protected areas, where certain regions are safeguarded from harmful activities. These areas can serve as sanctuaries for marine life, allowing ecosystems to recover and thrive. As we explore the potential strategies to mitigate human impact, we must also recognize the role of technology in advancing our understanding of ocean currents. Innovations in oceanographic research, such as the deployment of autonomous monitoring devices, allow us to gather real-time data on currents and water conditions. This wealth of information can inform management practices and enable timely responses to emerging threats. Imagine a future where our ability to monitor the oceans empowers us to make informed decisions that protect these vital ecosystems. The resilience of ocean currents is a testament to the dynamic nature of our planet. While human activities have undoubtedly disrupted their flow, there is hope in our collective ability to restore balance. Each step taken towards sustainability, conservation, and education can contribute to the nurturing of our oceans. It is a journey that requires commitment and collaboration, but the rewards are immense. As we navigate this path, let us remember that the ocean, in all its vastness and beauty, is a living entity that beckons us to protect and cherish it. In this delicate balance, the currents continue to flow, carrying with them the promise of life and the whispers of a vibrant, interconnected world. What future awaits us if we embrace our role as guardians of the ocean? The answer lies in our actions today, as we strive to understand and respect the rhythms of the sea. The ocean's currents, shaped by a myriad of factors, are now facing unprecedented challenges due to human activities. As we thread through the complex tapestry of influences, we can observe how the warming planet and the resulting climatic shifts are altering these currents in ways that may echo through generations. Climate change, a phenomenon driven by our collective actions, is causing the ocean to absorb vast amounts of heat. This rising temperature not only influences the water's density, but also affects the intricate system of circulation that governs ocean currents. Imagine the ocean as a delicate organism, each part reliant on the others for balance. When one aspect is altered, the repercussions can ripple throughout the entire system, leading to unexpected consequences. For example, as polar ice melts, the influx of freshwater dilutes salty waters, disrupting the density-driven currents that help maintain the ocean's circulation patterns. The concept of thermohaline circulation, often referred to as the global conveyor belt, is particularly sensitive to these changes. This system relies on the interplay of temperature and salinity to drive deep ocean currents. Picture a great wheel turning steadily as warm water from the tropics moves toward the poles while cold water descends into the depths. If the segments of this wheel begin to falter, through increased freshwater influx or temperature fluctuations, the entire mechanism may slow, leading to a cascade of changes across the globe. The implications of a disrupted conveyor belt are profound, affecting everything from weather systems to marine biodiversity. Furthermore, pollution introduces another layer of complexity to the ocean's currents. The introduction of excess nutrients into coastal waters, often from agricultural runoff, can lead to harmful algal blooms. These blooms not only deplete oxygen levels in the water, but can also alter the physical characteristics of the currents. Imagine a vibrant aquatic garden transformed into a toxic wasteland where once thriving ecosystems are stifled. As these blooms die off, the decomposition process consumes even more oxygen, creating areas where marine life struggles to survive. The presence of such dead zones can shift the dynamics of local currents, affecting nutrient distribution and the overall health of marine habitats. Coastal development, driven by the pressures of a growing population, poses additional threats to ocean currents. Urbanization along coastlines can lead to the construction of barriers that disrupt natural water flows. This alteration of coastal ecosystems can exacerbate erosion and sedimentation, further impacting the currents that weave through these environments. Imagine a river, once serene and flowing freely, now choked by debris and artificial structures, struggling to maintain its course. The modification of coastlines can redirect currents away from vital habitats, leading to a decline in local marine species that depend on healthy ecosystems for sustenance. As we contemplate these challenges, it becomes clear that the path forward requires thoughtful strategies to mitigate our impact on ocean currents. Restoration of coastal habitats serves as a crucial first step. By reintroducing natural elements such as mangroves and wetlands, we can foster resilience in coastal communities while simultaneously promoting the natural flow of currents. These ecosystems act as buffers, absorbing excess nutrients and protecting shorelines from erosion. Picture a thriving mangrove forest, its roots intertwining beneath the surface, offering sanctuary to marine life while safeguarding the delicate balance of the currents. Additionally, transitioning toward sustainable practices is paramount. The shift to renewable energy sources not only reduces greenhouse gas emissions, but also lessens the burden on our oceans. Imagine a world where solar panels and wind turbines harness the power of nature, providing clean energy while allowing the currents to flow unimpeded. Each small change we make in our daily lives can contribute to a larger movement aimed at restoring the health of our oceans. International cooperation is vital in addressing the global nature of ocean currents. The ocean knows no borders. It is a shared resource that requires collective stewardship. Collaborative efforts to monitor and protect marine ecosystems can create a unified front against the challenges posed by pollution and climate change. Consider the power of nations coming together to establish marine protected areas, where ecosystems can thrive without the pressures of exploitation. Such initiatives can serve as sanctuaries for marine life, allowing currents to flow naturally and nurturing biodiversity. As we explore these strategies, it is essential to recognize the role of technology in enhancing our understanding of ocean currents. Advances in oceanographic research, including the use of autonomous underwater vehicles and satellite observations, allow us to gather real-time data on current patterns and water conditions. This information is invaluable for informed decision-making and effective management of marine resources. Imagine a future where our ability to monitor the ocean empowers us to act swiftly in response to emerging threats, ensuring the vitality of these ecosystems for years to come. In embracing these strategies, we can foster a renewed relationship with the ocean, acknowledging its vital role in sustaining life on Earth. The currents, once altered by our actions, can be nurtured back to health through our collective efforts. Each step taken toward sustainability and conservation contributes to a broader legacy of stewardship, allowing future generations to inherit a vibrant and thriving ocean. As we reflect on the intricate web of influences shaping ocean currents, we are reminded of our connection to this vast body of water. The ocean is not merely a backdrop to our existence, it is an essential partner in the dance of life. What might the ocean teach us if we choose to listen? It calls us to act, to protect, and to cherish the currents that weave through its depths, nourishing the planet and shaping the climate for all who call it home. Chapter 9: Ocean Currents and Climate, a Complex Relationship. Ocean currents are not merely pathways of moving water, they are vital regulators of our planet's climate systems. Imagine vast rivers of seawater, winding through the depths, transporting warmth from the sun-kissed equator to the icy poles. This intricate network of currents plays a crucial role in distributing heat across the globe, influencing not just temperature, but also precipitation patterns and the very fabric of ecosystems. The ocean, in its entirety, acts as a massive climate control system, and the currents within it are the lifeblood that sustains this delicate balance. The Gulf Stream, for example, is a prime illustration of how ocean currents temper climates. As it flows from the Caribbean up the eastern coast of North America and across the Atlantic, it wraps Europe in a warmer embrace, allowing for a temperate climate that would otherwise be inhospitable. Without such currents, regions that are now verdant and vibrant would likely be stark and unyielding, swathed in ice and snow. Can you picture the dramatic shift in weather patterns if these currents were to falter? It is this ability to regulate global climate systems that underscores the significance of ocean currents in our world. Moreover, ocean currents are deeply intertwined with extreme weather events. As currents shift and change, they can amplify the intensity and frequency of storms. The connection between warm water and storm formation is a stark reminder of the ocean's power. Warm water provides the energy needed for storms to develop, and as ocean temperatures climb due to climate change, we can expect more ferocious hurricanes and typhoons. When we think of storms, it is easy to imagine the winds and rain, but consider the role the ocean plays in nurturing these tempestuous phenomena. The dynamics between warm ocean surfaces and the atmosphere above create a feedback loop, where rising temperatures lead to more intense storms, which in turn can alter ocean currents further. This relationship between ocean currents and climate change is complex and multifaceted. As the planet warms, the very mechanisms that drive ocean currents are beginning to shift. For instance, the melting of polar ice caps contributes excess freshwater into the ocean, disrupting the delicate salinity balance that is essential for the thermohaline circulation. This circulation, often referred to as the global conveyor belt, is driven by variations in temperature and salinity. Picture this conveyor belt as a massive, interconnected system that relies on each piece to function harmoniously. When one element is altered, be it through the influx of freshwater or changes in temperature, the entire system can be thrown into disarray. We are witnessing these changes unfold before our eyes, with currents slowing in some regions and accelerating in others. The Gulf Stream itself has shown signs of weakening over the past several decades, a phenomenon that scientists are closely monitoring. As currents shift, we can expect significant repercussions for weather patterns across the globe. Will certain areas experience unprecedented droughts while others face flooding? The unpredictability of changing currents poses a daunting challenge for communities globally. As we gaze into the future, the predictions for climate and ocean current interactions are sobering. Scientists are working tirelessly to model these interactions, trying to understand how continued warming will reshape both our oceans and our climate. Imagine a future where coastal cities must adapt to rising sea levels and altered storm patterns, where the very rhythms of nature are thrown into a chaotic dance. This future is not as distant as we might hope, and the implications of our current trajectory are profound. The interplay of ocean currents and climate serves as a reminder of the interconnectedness of all systems on Earth. As ocean currents shift, They do not operate in a vacuum. Their changes affect everything from marine life to terrestrial weather patterns. The whispers of the ocean speak volumes about the delicate balance that sustains life on our planet. Can we afford to ignore these signs? In the tapestry of life, the currents of the ocean are the threads that bind the climate together. They remind us of the intricate relationships that define our world, urging us to pay heed to the changes unfolding around us. As we contemplate the future of our planet, it becomes increasingly clear that understanding and respecting these natural systems is not just a scientific endeavor. It is a necessity for our survival. The stories of those who have dedicated their lives to studying these ocean currents are as compelling as the currents themselves. One such individual, a pioneer in oceanography, famously stated that to understand the ocean is to understand climate. This encapsulates the essence of our journey, an exploration of the depths that reveals not only the mysteries of the sea, but also the interconnectedness of all life on Earth. As we continue to unravel these mysteries, we are reminded of our responsibility to protect and preserve the delicate systems that sustain our planet. The ocean is a dynamic, living entity, and its currents tell tales of change, resilience, and adaptation. As we venture further into this understanding, let us remain mindful of our role within this grand narrative. The currents weave through time and space, reminding us of the importance of our actions and the ripple effects they produce. As stewards of this planet, we are called to listen to the ocean's whispers, to learn from its currents, and to act in harmony with the rhythms of nature. Will we rise to this challenge? The answer lies in our collective commitment to understanding and safeguarding the intricate balance of our world. The future is uncertain, but one thing remains clear. The relationship between ocean currents and climate is a complex tapestry that requires our attention. The currents are not simply waves of water. They are the pulse of our planet, guiding us toward a deeper understanding of the interconnectedness of life. As we ponder these connections, let us embrace the beauty and complexity of our oceans, for they are the lifeblood of our climate and the foundation of our existence. The ocean's currents remind us that we are all part of a greater whole, intricately linked by the very waters that sustain us. As we turn our gaze further into the intricate relationship between ocean currents and climate, it becomes essential to explore how these currents serve as the harbingers of extreme weather events. The ocean, with its vast, undulating surface, is not merely a passive observer in these phenomena. It actively contributes to the conditions that foster severe storms. When warm water temperatures rise, they create an energizing effect, fueling storms that can escalate in intensity. What happens to our planet when the ocean's temperature rises, becoming a catalyst for these powerful forces of nature? Consider the phenomenon of El Niño, a climate pattern characterized by the periodic warming of surface waters in the central and eastern tropical Pacific. This warming has profound implications for global weather, influencing rainfall patterns, droughts, and even the frequency of hurricanes. Imagine the ocean's surface as a mirror, reflecting the changes in temperature and currents that ripple through the atmosphere. As El Niño develops, its effects can cascade across the globe, leading to increased rainfall in some regions while others may face drought and famine. The interconnectedness of ocean currents and atmospheric conditions paints a vivid picture of a living, breathing system that is constantly in flux. The impacts of these extreme weather events are not just immediate. They carry long-term implications for ecosystems and human communities alike. When hurricanes make landfall, they can wreak havoc on coastal regions, leading to erosion, flooding, and destruction of habitats. The interplay of warm ocean water and atmospheric conditions creates a feedback loop, whereby warmer ocean temperatures lead to more intense storms, ultimately further altering ocean currents as the system adjusts to the new climatic realities. Can we truly grasp the magnitude of these changes and their potential consequences? As we delve into the feedback loops between ocean currents and climate change, it becomes apparent that the relationship is not straightforward. The ocean acts both as a buffer and a catalyst in the face of climate change. Warmer waters absorb more carbon dioxide, yet this process fosters ocean acidification, affecting marine life and ecosystems. Imagine a world where coral reefs, the vibrant cities of the ocean, begin to fade, their colors dimmed by increasing acidity. The loss of these ecosystems not only affects the myriad species that call them home, but also disrupts the currents that may depend on their structure and health. The melting of polar ice caps serves as another poignant example of how feedback loops can exacerbate climate change. As ice melts, it introduces fresh water into the ocean, disrupting the salinity and temperature gradients that drive thermohaline circulation. This process can lead to further changes in ocean currents, which may in turn influence weather patterns, creating a cycle of disruption that is difficult to halt. What happens when the very mechanisms that have maintained stability begin to unravel? It is a question that looms large as we consider our future. Scientists are now tasked with forecasting potential scenarios that could unfold in the coming decades. The predictions are sobering. With continued warming, we might see currents shift in ways that lead to drastic changes in weather systems. Imagine coastal cities grappling with rising sea levels and more frequent flooding, while inland areas experience prolonged droughts. The delicate balance that sustains ecosystems and human societies hangs in the balance, teetering on the edge of an uncertain future. As we ponder the potential outcomes of these changes, it is crucial to recognize the stories of those who work tirelessly to understand these dynamics. Researchers and oceanographers are employing cutting-edge technology and innovative approaches to study ocean currents and their climate connections. Their efforts remind us of the importance of scientific inquiry in illuminating the complexities of our world. As one noted scientist stated, "Science knows no country, because knowledge belongs to humanity." This spirit of collaboration and shared knowledge is vital as we confront the challenges ahead. In light of these uncertainties, the need for adaptive strategies becomes increasingly apparent. Communities worldwide must prepare for the impacts of shifting currents and changing weather patterns. What steps can we take to safeguard our coasts, protect vulnerable ecosystems, and ensure food security as climate patterns evolve? The answers lie in a collective commitment to resilience and sustainability, recognizing that our actions today can shape the future of our oceans and the climate they influence. The journey we are on is one of discovery and responsibility. As we continue to explore the intricate dance of ocean currents and climate, we must remain vigilant, listening to the lessons the ocean offers. Each wave, each current, speaks to the delicate balance of life on Earth. What stories will we tell in the years to come, and how will we ensure that the currents of our oceans remain a source of life and vitality rather than a harbinger of turmoil? As we move forward, let us embrace the interconnectedness of our planet. The currents of the ocean remind us that we are all part of a greater whole, woven together by the very waters that sustain us. To understand and protect these currents is to honor the intricate web of life that exists on Earth. Will we rise to meet this challenge, becoming stewards of the ocean and champions of a sustainable future? The path is not yet clear, but the journey is one we must undertake together. Chapter 10: The Future of Ocean Currents, Challenges and Research. Emerging research areas in ocean current studies are rapidly evolving, driven by advancements in technology and a growing understanding of the complexities of our oceans. Scientists are now employing sophisticated satellite observations and autonomous underwater vehicles to gather data that was once beyond reach. These innovations allow researchers to visualize ocean currents with remarkable precision, revealing intricate patterns that are essential for understanding climate dynamics. One exciting frontier is the study of the interactions between ocean currents and marine ecosystems. The movement of water not only influences temperature and salinity, but also affects the distribution of nutrients and the health of marine life. Imagine a delicate balance where the currents act as conveyor belts, delivering essential nutrients to the vibrant ecosystems that thrive along coastlines. Scientists are beginning to unravel how changes in ocean currents, driven by climate change, could impact these ecosystems. For instance, shifts in current patterns may affect fish migration routes, leading to changes in population dynamics and food availability for both marine species and the communities that rely on them. Another emerging area of research focuses on the role of ocean currents in carbon cycling. Oceans absorb a significant portion of the carbon dioxide emitted into the atmosphere, acting as a buffer against climate change. Understanding how currents facilitate this process can provide insights into the ocean's capacity to mitigate climate impacts. Researchers are investigating how variations in current strength and direction influence the distribution of carbon-rich waters. Can we envision a future where enhanced understanding of these dynamics informs climate policies and conservation efforts? Monitoring ocean currents is vital for climate science, as they play an essential role in regulating the Earth's climate systems. The currents are interconnected with atmospheric patterns, forming a web of interactions that influence weather and climate across the globe. By tracking these currents, scientists can gain insights into how changes in temperature, salinity, and wind patterns affect the larger climate system. Consider the implications of modern technology on monitoring efforts. With advancements such as high-resolution ocean models and satellite altimetry, researchers can now observe real-time changes in oceanographic conditions. This capability allows for more accurate predictions of extreme weather events, such as hurricanes and typhoons, whose intensity can be influenced by ocean currents. As we look to the future, predictions for ocean currents under global change paint a concerning picture. Climate models suggest that as temperatures continue to rise, the very patterns that have governed ocean currents for millennia may begin to alter significantly. The melting of polar ice, for instance, introduces large volumes of freshwater into the ocean, disrupting the delicate balance of salinity and density that drives thermohaline circulation. Can we imagine the cascading effects of these changes? Researchers warn that shifts in ocean currents could lead to more extreme weather patterns, affecting everything from rainfall distribution to the frequency of storms. The Gulf Stream, a critical current that influences the climate of North America and Europe, is projected to weaken under the pressures of climate change. Such alterations could transform temperate climates into more extreme environments, with profound implications for agriculture, water resources, and biodiversity. Public awareness and policy play a crucial role in protecting ocean currents, and, by extension, the climate. Engaging communities in the dialogue about ocean health fosters a deeper understanding of the interconnectedness of our actions and the ocean's responses. Educational initiatives can empower individuals to make choices that reduce their carbon footprint, while advocacy for sustainable practices can influence policymaking on a larger scale. Imagine a world where informed citizens rally for policies that prioritize ocean conservation and climate action. Such collective efforts could lead to significant changes, from reducing greenhouse gas emissions to protecting marine habitats. A comprehensive approach that integrates science, community engagement, and policy advocacy can create a protective shield around our oceans, ensuring that the currents continue to flow, nurturing life and regulating climate for generations to come. The future of ocean currents is not solely in the hands of scientists and policymakers. It rests with all of us. By fostering a culture of awareness and responsibility, we can contribute to the protection of these vital currents. As we reflect on the intricate relationship between human activities and ocean health, it becomes clear that our choices today will shape the currents of tomorrow. In this journey, the role of innovative research cannot be overstated. As scientists delve deeper into the mysteries of ocean currents, their findings will inform our understanding of climate processes and guide the actions necessary to protect our planet. The challenges ahead are formidable, but with concerted effort and a commitment to understanding the ocean's vast complexity, there is hope for a future where ocean currents continue to flow harmoniously, sustaining both marine and human life. The future beckons us to embrace our role as stewards of the ocean. By recognizing the importance of monitoring ocean currents and supporting research efforts, we can pave the way for a healthier planet. As we stand at the precipice of change, let us envision a world where ocean currents thrive, a world where our actions contribute to the balance of nature, ensuring that the gentle rivers of the sea continue to weave through the tapestry of life on Earth. The exploration of ocean currents is entering exciting new territory, with researchers venturing into domains that promise to deepen our understanding of these vital systems. One such area is the study of biogeochemical processes, particularly how ocean currents influence the cycling of nutrients and pollutants. As currents transport water across vast distances, they also carry with them a multitude of substances, from the essential nutrients that support marine life to harmful pollutants that threaten it. Imagine the currents as both highways and conduits, facilitating the exchange of energy and materials across the globe. Innovative studies are now examining the effects of microplastics and other contaminants on marine ecosystems, as currents can spread these materials far beyond their original sources. Researchers are investigating how these pollutants interact with marine organisms. Could the currents, in their ceaseless flow, act as agents of both distribution and dilution? Understanding these dynamics is crucial, as they can inform policies aimed at reducing ocean pollution and protecting marine biodiversity. Another captivating frontier lies in the realm of ocean-atmosphere interactions. The exchange of heat and moisture between the ocean and atmosphere is a critical process that affects weather patterns worldwide. Scientists are beginning to employ advanced modeling techniques to simulate how changes in ocean currents might influence atmospheric conditions. As we ponder this connection, can we visualize the ocean as a vast thermostat, regulating temperatures and weather patterns on land? This interplay becomes particularly significant in the context of extreme weather events. By enhancing our understanding of how ocean currents affect atmospheric phenomena, researchers hope to improve predictive models for storms, droughts, and other climate-related challenges. For instance, the El Niño phenomenon, characterized by the warming of ocean waters in the central and eastern Pacific, has far-reaching effects on global weather patterns. Exploring the nuances of how ocean currents contribute to such events can provide critical insights for disaster preparedness. As the importance of monitoring ocean currents becomes increasingly clear, so too does the need for more robust observational systems. Modern technology, such as autonomous underwater gliders and buoys equipped with advanced sensors, is revolutionizing our ability to collect data on current dynamics. These tools allow scientists to gather real-time information on temperature, salinity, and current speed, enriching our understanding of the ocean's behavior. Imagine these devices as vigilant sentinels, continuously relaying vital information about ocean health and changes. The integration of data from various sources is essential for developing comprehensive models of oceanic processes. These models can help predict how currents will respond to ongoing climate change, providing invaluable information to policymakers and marine conservationists. The significance of this predictive capability cannot be overstated. It empowers us to take proactive measures in safeguarding marine ecosystems and mitigating climate impacts. The challenges posed by climate change extend beyond mere predictions. As ocean temperatures rise and ice melts, the consequences for ocean currents are profound and multifaceted. The rate of sea level rise is accelerating, and as freshwater from melting glaciers enters the ocean, it alters the delicate balance of salinity and density that drives current systems. What effects might this have on the thermohaline circulation, a critical component of global climate regulation? Scientists are grappling with the potential implications of a weakened thermohaline circulation. Some models suggest that this could lead to significant shifts in climate patterns, particularly in regions that rely on stable ocean currents for their weather systems. The potential for altered precipitation patterns could transform landscapes, impacting agriculture and freshwater resources. Can we envision the cascading impacts of such changes on human societies and natural ecosystems? Public awareness of these challenges is paramount. Educating communities about the importance of ocean currents and their role in climate health can inspire collective action. Imagine coastal communities rallying together, driven by a shared understanding of their unique relationship with the ocean. Such awareness can foster stewardship, encouraging individuals to engage in sustainable practices that protect marine environments. Policy initiatives can also play a transformative role in safeguarding ocean currents. Governments have the opportunity to implement regulations that limit pollution and promote sustainable fishing practices. By prioritizing ocean conservation, policymakers can create a framework that supports the health of marine ecosystems. What kind of policies could effectively address the threats posed by human activity to ocean currents? Integrating scientific research with policy development is essential for creating effective conservation strategies. As scientists uncover the complexities of ocean currents, their findings can inform the creation of marine protected areas, sustainable fishing quotas, and pollution regulations. By fostering collaboration between researchers, policymakers, and local communities, we can build a holistic approach to ocean stewardship that addresses both immediate and long-term challenges. In this intricate interplay of science, policy, and community engagement, the future of ocean currents rests on our collective shoulders. As we confront the challenges of climate change and environmental degradation, it is imperative that we act with urgency and purpose. Let us envision a future where informed decisions are made, reflecting a deep understanding of our ocean's vital role in sustaining life on Earth. Through continued research, innovative monitoring, and unwavering public engagement, we can nurture the currents that connect us all. The ocean, with its boundless depths and intricate flows, holds the key to a sustainable future. It is our responsibility to ensure that these currents continue to thrive, flowing like lifeblood through our planet, nurturing both the seas and the communities that depend on them. As we navigate the future of ocean currents, emerging research is shining a light on the vital role these currents play in our planet's health. One area of particular interest is the study of ocean acidification, a phenomenon linked to increased carbon dioxide levels in the atmosphere. As oceans absorb carbon dioxide, they become more acidic, which can have devastating effects on marine ecosystems. Coral reefs, often called the rainforests of the sea, are particularly vulnerable. Imagine vibrant coral gardens, once teeming with life, now struggling to survive in increasingly acidic waters. Researchers are investigating how varying ocean currents may either exacerbate or mitigate the impacts of acidification. The movement of currents can affect the distribution of carbon-rich waters, influencing the extent to which different marine habitats are exposed to these changes. This exploration is crucial, as it may reveal strategies for protecting vulnerable ecosystems and maintaining their resilience in the face of climate-induced challenges. Moreover, the study of ocean currents is deepening our understanding of their role in the distribution of biodiversity. Currents can act as both corridors and barriers for marine species, facilitating migration and dispersal while simultaneously isolating populations. This dynamic is especially significant for species that rely on specific habitats, such as seagrass meadows and kelp forests. Can we visualize the currents as conduits of life, shaping the very communities that thrive within the ocean's embrace? The implications of these studies extend beyond the realm of marine biology. They weave into the fabric of climate science, as understanding the interconnectedness of currents and ecosystems can inform conservation efforts and climate adaptation strategies. By recognizing the multifaceted roles that ocean currents play, scientists are better equipped to propose holistic solutions that address both ecological health and climate resilience. Public engagement remains a cornerstone in this journey toward understanding and protecting our oceans. Initiatives that foster citizen science, where individuals contribute to data collection and monitoring efforts, are gaining momentum. Picture a community of beachgoers, equipped with simple tools to observe and report on ocean conditions. Their contributions not only enhance scientific understanding, but also nurture a profound connection to the ocean and its currents. Such involvement can spark a collective sense of responsibility, encouraging sustainable practices and advocacy for environmental protection. Policy frameworks are also evolving to better encompass the latest scientific findings about ocean currents. Governments and organizations are recognizing the need for adaptive management strategies that account for the changing dynamics of ocean systems. This adaptive approach allows for more responsive measures that can mitigate the impacts of climate change on ocean currents, thereby safeguarding both marine ecosystems and coastal communities. As we reflect on the challenges and opportunities that lie ahead, it becomes clear that our relationship with the ocean is both complex and vital. The currents that flow through our seas are not merely physical phenomena. They are integral to the health of our planet. By fostering a culture of awareness and stewardship, we can ensure that these currents continue to thrive, nourishing life and regulating climate for generations to come. In this intricate web of science, community, and policy, the future of ocean currents will be shaped by our collective actions. The journey forward invites us to harness the power of knowledge, innovation, and collaboration, empowering us all to be champions of the ocean. Let us embrace this challenge with open hearts and minds, ready to protect the lifeblood of our planet and the currents that connect us all.